Hello. So let's continue. This is question 3, physics 1010. So here we have this dry ice being placed in a test tube, and the mass of this ice is about 0.4 grams, and the volume of the test tube in which it is placed is 22 cubic centimeters. Right. So we want to find the final pressure of this gas if it is laid to vaporize and reach a thermal equilibrium with the surrounding at a temperature of 27 degrees Celsius. All right, so this is solid carbon dioxide. Okay, so we just want to find the pressure of this solid carbon dioxide after reaching thermal equilibrium with the surrounding. All right, so this is a very simple case. Here we are simply going to apply the ideal gas law and obtain the pressure of this ice, okay, at that given temperature of 27 degrees Celsius. So notice that what we need first of all is to uh, consider the number of moles, because we know that PV equals nRT. So we have P, that is which we are looking for. We want to find the pressure. But we also need the number of moles so that we can have only one unknown in this expression. Okay. So the first step is to actually find the number of moles and also to consider the data that we were given in the question. So the volume of that test tube we are given is V equals 22 cubic centimeters. We convert it to standard units of 22 times 10 to the minus 6 cubic meters. The temperature also at thermal equilibrium is 27 degrees Celsius converted to kelvins, and we are having 300 kelvins. Okay, so now what is the pressure given this volume and at that temperature? Okay, so notice that the ideal gas law here is giving P equals nRT over the V. All right, but we need N first, the number of moles, okay, which is the first step. As you can see, considering the molecular mass of carbon dioxide is 44 grams per mole, and the mass of the given solid carbon dioxide, which is the ice, is 0.4 grams. So from this we're able to obtain the number of moles by using the mass over the molar mass, which is 0.4 divided by 44, and we get 9.09 times 10 to the minus 3 moles. Okay, so these are the moles of this dry ice or solid carbon dioxide. So now that we have found the number of moles, we proceed now. We substitute those values into our equation here, the ideal gas law. And as we do that, we say P therefore equals the number of moles for this gas multiplied by the constant multiplied by the temperature divided by the volume of the test tube. Okay, so from here you can see it is very simple. We are able to obtain the value of the pressure as P equals 1.03 times 10 to the power 5 pascals. Okay, so this again was very easy. So it's just a matter of finding the pressure of this gas when it reaches thermal equilibrium, rather the pressure of the solid carbon dioxide once it reaches the thermal equilibrium, and also to consider that we need to know the number of moles of this ice, okay, So we go the usual way of obtaining the number of moles that we know even back in high school. So N equals mass over the molar mass gives you the number of moles, and then substitute that value into the ideal gas law and you get your pressure. Okay.